So, welcome back to this final lecture on this unit, guys. So, let us discuss about the floating point division. Okay. So, floating point division, right? So, quickly tell how to do this. You can guess this. For example, I have this two numbers 298 into 10 power 5. Okay, let me add this bias, right? 0.654 into 10 power 9 plus bias, right? So I wanted to divide these two numbers, right? So what I do, these are the mantisas, just divide the mantisas, right? 654, do this division. So this division is same as the fixed point division, right? This numbers can be assumed as fixed point numbers. I told restoring method, right? You can use the same method for doing this division, right? So, and how to tackle with the exponents, subtract the exponents, right? In case of multiplication, I add the exponents. In this case, I need to subtract. If I do subtraction, what happens? You can observe here. So this will remain same into 10 power 5. Bias will go 5 minus 9. So this will remain same into 10 power minus 4. But there is no bias. So after division, what I need to do? I need to add bias to this. Explicitly I need to add this. Why means bias is gone. If I subtract the two exponents, bias will be gone. So I need to explicitly add this bias. This is the first point you need to understand. So divide the mantises and subtract the exponents. And after subtracting the exponents, I need to do bias correction, right? So the next thing you need to understand is, so I told that while doing division, if you remember, we have taken one input in the AC, another input in the QR according to this, right? So these two registers have taken numerator. So denominator we have taken in the BR, right? So like we have taken, for example, if AC is 5 bits, QR is 5 bits. So I am assuming, okay, so mantis Q is 5 bits, B is 5 bits, right? So 10 bits by 5 bits, right? 5 bits, okay. I get the quotient 5 bits and remainder as 5 bits. So this is what the this is what the fixed point we did, right or not? Now in case of floating point, what we are doing is I am taking floating point number in the AC, so another floating point number in the BR, right? So I am not considering QR. So I get so again in this case let us consider the mantisas. Why we are interested in mantissa division, right? So I am okay. So signs, so first for example, so this AC is represented with AS, you know, right, and A and small a, right? This is the sign, this is the mantissa, this is the exponent. Similarly, right, so BS, B and small b. So we are interested in this capital and capital V. Why means these are the exponents, we are subtracting them, right? AS and BS decide the sign of the result, sign of the quotient, right? You know that, right? If both are positive, it's positive. If both are negative, positive. If positive, negative, negative, positive, the result is negative. You know this, right? So that is the result of the quotient, sign of the quotient. AS, BS decides the sign of the quotient. But now I am interested in A by B, right? Now see here. So now I am interested in A by B. So in this case, what I told, so if okay, so in this case, if A is greater than B, right, there is a overflow, right? There is a overflow. Overflow means I get a quotient more than 5 bits. That is the overflow condition. So this is a exception in this case. Here also the same rule applies, right? So what is the rule? So but in this case, what happens in case of fixed point, what we did, in case of overflow, we have raised an exception and stopped it. We have raised an exception by setting this overflow flag as 1 and we just stopped the computation, right? So but in this case we can avoid this. So even if there is a overflow, we can correct the overflow. How it is possible that? See here, what we do is, so in this case we have A by B, we detect for the, we check for the overflow. How we check for the overflow? We need to if A is greater than B, there is a overflow. How to identify that? Just perform A minus B, that is A plus B bar plus 1, right? These are the mantises, right? So if we seek the carry, right? So if the carry equal to 0, right? So A less than B. So in this case there is no overflow. Very good. No need to do any correction. But if E equal to 1, what is the meaning? A is greater than B, there is a overflow. So what I can do is, if A is greater than B, I can ensure that A is less than B. How to ensure that? Just perform one time right shift, right? So if I right shift the A, so just perform one time right shift of A, right? So just perform one time right shift of A, right? So how to perform right shift of A? Just perform right shift of A and add the exponent. So whenever I perform the right shift of a mantissa, then I need to add the exponent. So this way, if I do this one time, then automatically what happens? This ensures that A is always less than B. So in case if I detect a overflow condition, just I can avoid that overflow by performing one time right shift and adjust the exponent. So this is why floating point has a advantage of avoiding the overflow, right? So this is enough basic. So let us go to the algorithm now, right? Now, yeah, this is what the algorithm. Okay. Now see here. So first of all, the numerator, right, is there in the dividend, is there in the AC, divisor is there in the BR. I am trying to perform AC by BR, right? So definitely if BR equal to 0, what is the meaning? There is a divide by overflow. Just raise an exception. This is what one exception. Just raise the exception and end the algorithm, right? Divide by overflow. But if BR is not equal to 0, just proceed with the algorithm, right? Maybe AC may be 0, right? In that case, what quotient is 0? So, right? So in this case, what we are trying to do? First, let me explain this. So first, I am trying to do AC by BR, and I want to store the quotient in the QR, right? And quotient. So two answers I get, right? Quotient in the QR, and remainder remain in the AC, right? Remainder remain in the AC. This is what the outputs. So these are the inputs, right? Numerator AC, denominator BR, quotient is there in the QR, remainder is there in the AC, right? So now BR equal to 0, divide by 0, but if AC equal to 0, just quotient will be 0. So just make 0 and end the algorithm, right? So if both are not equal to 0, then proceed with the algorithm. What is algorithm? First decide the sign of the result. So based on the sign of the numerator and sign of the denominator, I can decide the sign of the quotient by XOR gate. Just now I told, right? If both are positive or both are negative, the sign is positive. If one is negative, one is positive, or one is positive, one is negative, the sign is negative. That is, we can perform the XOR gate and identify that. Also initialize the quotient with 0, right? So here Q is initialized with the 0. This is just initialization, and we establish a count. You know, this count is going to use how many times we need to use the count here. While dividing the mantises, I need to repeat the iterations, right? You know this algorithm, restoration division. So this is a restoration division. For performing this restoration division, how many times I need to repeat these iterations? So that count I put in the sequence counter. Then start the algorithm. So first thing is I need to detect the overflow. 1 minute. So detect the overflow. So how to detect the overflow? Just perform A minus B, right? So A minus B, right? So I perform A plus B bar plus 1. Now based on the end carry, right? So if end carry is 0, right, there is no overflow. But if end carry is 1, there is an overflow, right? So first of all, in both cases, if there is no overflow, I did A minus B, right, and the result A value will be A minus B. But to perform the division, I need to get back the original value of A, right? So to do that, here I did A minus B. To get back the first original value, in both cases I did A plus B, so that A value remains in the A. To perform the mantissa division, A value will remain in the A, right? So in this case there is a overflow. So how to avoid the overflow? One time shift right, right? One time shift right. Whenever we shift right the mantissa, just one time add the exponent, right? So after that, right, now we proceed with this, right? So once we do this, we need to subtract the exponents, right. So as part of the division algorithm we need to subtract the exponents. So I need to do a minus b, subtract the exponents. So a minus b I can do with a plus b bar plus 1. So once I subtract the exponents I need to adjust the bias, that is what I told, right. Once I adjust the bias, so I am storing the quotient in the q, so I need to get back the a value to the q, right. So so exponent of the quotient I need to get back to the q. Why means qr is storing the result of the quotient. So this exponent of the quotient I need to get back to the q. Then I perform the division with normal mantissa division using the same restoration algorithm, right. Using the same restoration algorithm I perform the this same algorithm I perform the division, right. Okay. So this is what the division of floating point numbers. Okay. So thank you.